just shows up now for everybody with just my slides and not all kinds of other stuff on my screen. Okay, cool. So thanks for having me. My name is Jesper Kruse. My company is Maine Passive House. And what you're seeing here is my own house that's in the middle of the retrofit that we did. Started with us having some wooden windows. So we built the house 20 years ago. And after 15 years, the wooden windows that we bought were just toast. So we had to change the windows, and that kind of that was what kind of catapulted me into this retrofit where we did one side a year until we finally got sick and tired of it and did the last two sides in 1 year. I can just say that I am really happy we did it. The house is extremely comfortable. You can tell that the air in the house is just, the air quality is much better than it used to be. The house is really resilient. It gets below 0 degrees Fahrenheit here. And, you know, we can leave the house unheated and come home and the temperature won't drop. It'll never freeze inside. I can say that for a fact. So I'll talk a little bit about money at the end, but jump right into it here. So what we had originally was, you can see we had it's a slab on grade, frost walls with a slab. So we have our frost walls. We have a concrete slab with 2 inches of XPS foam below, so that's existing. Have a 2x6 wall, original, and then a set of trusses up on top. So what we did is we laid out an airtight membrane, added a 9.5-inch Larsen truss, a TJI, to the outside, installed triple pane windows and mechanical ventilation systems, added more cellulose up in the ceiling, and that's kind of like the quick breakdown. So the foundation, we took our airtight membrane, which is a DA membrane from Proclima. We attached that to the foundation, and then we added 10 inches of EPS foam down to the bottom of the footers. Here it is when it's all done. We wrapped some tar paper around it to try and keep the critters out. And then that's really all that happens to the foundation. Here's a little detail. Not much to say there. Put it in so if people are going back later to see the presentation, I want to check out the details, you can kind of spend a little more time on it there. So here you can see our the airtight membrane. All the seams are taped. We have our window box, have a little piece of Mento that we wrap down below here. Mento plus membrane that goes under the trusses, so that can get wrapped up. Blocking around the windows, you can see our Lunas units, which are the ventilation units, kind of sticking out through the wall there. And here's the detail again. With the air barrier really being the important part. We like to have it in that 1/3 from the inside of the house, ideally. And then we have the Mento Plus that goes on the outside of that. You can see the wire penetration sealed up here with some neat little things. And here's the project with a rain screen. So we're having a rain screen in here right behind the cladding, so that can vent all the way up. That eventually connects all the way up to the roof. And that's how the whole outside of the building kind of gets vented. Not much more to say there. The roof, the biggest hurdle and challenge. So what you're seeing here is the DA membrane that we brought up the wall, and then we draped it out over the TJI or Larsen trusses, so that the walls are kind of sealed onto themselves. And then from there, the Mento then gets wrapped up over the roof, so we can kind of wrap the whole house in like a neat little package, rather than having the rafter tails sticking out, you know, and having to tape around those to make it all airtight. Then we cut out about 3 feet of plywood up along the ridge, being so that this used to be a vented attic space, and now we're sealing the whole attic up. So the thinking here is that the Mento plus membrane that has a high perm rating will allow moisture to get out through these gaps here, rather than having to try to get through the plywood, which doesn't have that high of a perm rating. Bolted some new rafter tails on here, vented the whole roof so that there's airspace going up through there. This is actually just spaced up, so there's still air going through here. So it's coming up along our walls, and then it goes all the way up through the roof, and it vents out up in the ridge. And put a roof on, and we had my roofing guy bent up some special, very wide drip edge panels so that we could use the existing roofing panels. Again, since there's still life left in those, so rather than throwing them out, we found a way to reuse them. The attic, definitely the biggest challenge of the whole project. Used to be ventilated, and now the thought is, what happens if we have moisture that migrates from the inside of the house and gets into the attic? Does it get out through that Mento membrane up in the top? I really like to try and keep the moisture from getting in there in the first place. So we had 16 inches of loose fill cellulose up in the attic to start with. So it's a bit of a challenge, but the snow shovels, we kind of cleared it out of the way. And then we took Intello membrane, another product from Proclima, and we pre-cut the membrane so that it would fit around these cross braces in the trusses, brought it up there, stapled it down, and then very carefully taped that to the cross braces, taped up in here where there are like little gaps and stuff. And it was tedious, but I'm really happy that I did it. I feel like that was a critical part of the whole project. And obviously at some point it would be nice to climb up in that attic and see what's going on, but I don't have easy access, so I'll let you guys know when I make it up there. So Anna, Matt, and I here, we're all excited, getting ready to go up there and kill this project. And we did it in the beginning of May. It's probably like not even 70 degrees outside, I think like 20 degrees centigrade. And it was probably like 120, like 55 degrees Celsius up in that attic. It was very, very hard work, not a lot of fun, but we got it done. And we did one side. What we learned from doing one side of the wall, and when we came over to the other side, what we realized is if we just cut the plywood off the bottom of the roof, then it'd be a lot easier to attach this Intello membrane from a set of staging and just work on it right there, getting all these connections taped up really well. We did put down some EPS foam along these edges here, just so that we had something solid that we could push down on as we were working the tape, in the connection from the truss to the tape. And then the ceiling around the chimney here, just have two pieces of metal that slide in from either side, and where they overlap, we caulk it, and then put some high temperature caulking around the chimney, which is what Anna is doing in this photo here. On the inside, we added a 2-inch by 2-inch equilateral triangle piece of EPS foam, seeing that the trusses where the walls and the walls and the roof are meeting, there's only like 3.5 inches of insulation. So we wanted to do something to kind of alleviate that thermal bridge there. And it was a balance between adding insulation and eliminating the thermal bridge, and still trying to keep that outside connection somewhat warm so that we don't get condensation out there. So you can see in this thermal image camera photo up here that, you know, it is a little bit colder right in that connection, but it's not horribly bad. So then we just put a piece of painted wood over it, so kind of blends in fairly decent. Decks and porches. For the new deck that we added onto the house, we just bolted on these metal straps that we had fabricated. We bolted those onto the rim of the deck before we installed it, and then We just bolted those straps into the TJI, or the Larsen truss. So that whole deck here is just hanging right off the building. And is it strong enough? We get a lot of snow up here, and several feet sometimes, and that all slides off the second story and comes down and lands on this deck. And the deck is still hanging on the existing porch that we had. And you guys are all welcome to hire me for your drafting projects here. We removed some decking boards in here, and then we dug down as far as we could get. This deck is very close to the grade, so it wasn't easy work, but we dug down as far as we felt like we could to insulate the exposed part of the foundation, and then some. And then we added some vertical foam insulation. It's actually much closer to the grade here. So, and then we insulated in between the rims, and what it looks like is this. So you have the insulation down below, the vertical insulation that's kind of preventing the frost from creeping into the ground underneath there. Some wood that's holding it in place, a little bit of spray foam to make it nice and tight. And what you're looking at here is the rafters coming into the building, the collar ties. So the collar ties, we cut them back so that we could run our airtight membrane right up behind that, and then we taped that to the rim, taped it up above to the rim. We could also get our weather-resistant barrier, our Mentor Plus, in behind this, behind the collar ties. So that's as far as I was willing to go in terms of demolishing. Ideally we would have detached the whole porch, but I just wasn't willing to go that far. So got to make some compromises when you do a retrofit, for sure. Mechanical systems, we're using Lunas units for ventilation, and the benefit obviously to these are that it's all within the one unit, right? There's no duct work required, so obviously makes it much more attractive when you're doing a retrofit and you're not tearing the entire inside of your house apart. So just to make it clear, the inside of the house, we didn't really change anything to that. For heat, we have a single 12,000 BTU air source heat pump that's mounted kind of between the first and the second story. And that will easily warm the whole house. Doesn't really cool the upstairs. I don't really care about air conditioning, but we tried, and it will cool the downstairs, but not the upstairs. Then we have a wood stove with a dedicated air supply coming in through the back that we're very happy with. It works really well. I know if we were trying to get this project certified through the Passive House Institute, there would probably be all kinds of loops that we would have to jump through with the Passive House Institute to the concern is that, like, you have a wood stove in a passive house, you have a ventilation system, do you potentially get like a negative pressure inside the house? Could you potentially like be pulling the smoke out of the wood stove and into the living space and killing everybody? Definitely a legit concern, I think, but I haven't had any issues with it. For the hot water, I wanted to try and put in a heat pump water heater, thinking that the heat pump part, so you can turn them to electric. So I was thinking, well, we'll turn it to electric in the winter, and then in the summer, when it's warm in the house, we can run the heat pump, and it will cool the house. It will dehumidify the house, and it definitely does, to the point where it's just like uncomfortable. So even on the hottest days of the year, the bathroom that is next to our utility room is still like uncomfortably cold. So I would definitely not recommend getting hot water that way. I would probably just, if I was doing it over again, I would just get a really well insulated electric hot water tank. Materials, just a quick word about that. We used membranes and dense packed cellulose primarily for the airtightness and for the insulation. And from what I've heard is, if you go out and you build a passive house and you're using like, closed cell spray foam or a bunch of XPS foam, You could potentially build a passive house that releases more carbon over its life compared to like a code-built house built with better products. So if you are concerned about climate change, you should definitely pay attention to what materials you're using. And I think the money part, I think is the last little bit about it. We spent almost $160,000 in this project. The house is about 2,000 square feet, so it comes out to $81 a square foot. We had to replace the windows, and the siding that we installed originally, we kind of screwed that up. So I could argue that that has to be replaced as well. So I don't know if the cost of the new windows, the installation, and the siding would come to maybe, if you're in a good mood, you could say like half of the total cost. So, you know, it's not an inexpensive endeavor to retrofit your house to a passive house, I would say. And this, of course, is, you know, my company and my employees from my company did the work, but this is like kind of calculated as if I were paying full price for it. So, you know, if you're doing the work yourself, you can obviously do it for a lot less money. And that's it. And here's the house now that it's all done, and we're happy with it. So that's my thing.
Sorry, Jesper, I was just getting the.
Thank you so much, Jesper, for sharing that all with us.
Let me just ask a quick, do you want me to stop sharing this or on the screen? Does that matter?
Jesper, I would say just leave it open for a second, because there's a few people that wanted to go back and look at the rafter details. So if you want to go back, and maybe what I'll do is, I think, was it Tom that had it, or was it Jeff? So I think, sorry, just go back.
Detail right here?
Yeah. So if you leave it right there, and just want to explain that, because I think Susan and Jeff had questions about it. So just kind of, again, describe what's going on with how those are attached. And
oh, got it. No, I see it.
I know we made Jesper kind of rush through these things, and so he skips, you know, maybe 5 seconds too fast on this slide. But again, you want to just go through how you did that detail?
Yeah, so we just took, these are just 2x4s, and we you know, we cut these blocks here with the bevel of the roof. We screwed them to the 2x4s. So we prefabbed all those on the ground, and we brought them up on the roof. And then we just bolted them through the 2x4 into the existing rafters, and they're just hanging off here. And, you know, then eventually we run a string here, cut all those back, and put a sub fascia on it. But super rugged, definitely no concerns there in terms of it not being strong enough.
So it's two pieces of wood that form a T, right?
Exactly.
Right.
That's correct.
And so
yeah.
So is it 2x4 to a 2x4, or 2x4 to a 2x6, or
2x4 to a 2x4?
Oh wow, okay.
And then, you know, I think the key to it is that, you know, the heel of that lower 2x4 is tight against the old rafter, right? So as that roof is trying to sack down, you know, it can't, that connection between the heel and the old rafter is tight, and it keeps it from being able to sag. You know, if that was just kind of like hanging out in midair, I would be much more concerned about it sagging. And then, you know, when we're building the rain screen, we're making sure too that the rain screen comes up and has a little bevel, right? So it just gives that little added extra support to help hold this up.
And what is the projection of the overhang?
16 inches.
Thank you.
Yeah,
I tell you, I have a house in northern Vermont that I'm thinking of doing something like this too. So this is just so perfect.
Well, I'm glad you like it.
Jeff, I think there's a lot of people, I mean, even the detail of how you kept the roofing material and you just added that extra, whatever, 16 or 24 inches of new metal to keep the old roof. I mean, that's just, again, great way of dealing with resources.
Yeah, it just seemed like, the roof was still in decent shape. So why throw it out and buy a brand new roof?
Yeah. Okay, we'll keep going with questions. Thanks for that, Jeff. And I think that was Susan's as well. So going back up to Tom Bissett Dilly, you were actually first in the queue. I don't think we answered your question. So, Tom, are you there?
Yep, just had to unmute.
No problem.
I didn't see what the walls were filled with. Was there a picture of cellulose and I missed it, or is it EPS outside?
It's all cellulose. So
great. And the sheathing is on the exterior did you sheath it with a fiberboard or just
no,
the
the sheathing?
The Mento?
Just the Mento, and then it's 1x3 strapping that's nailed into each Larsen truss or TJI, and then there's just a little skinny piece of strapping that's put in. So that's 2 feet on center, right? That's a TJI, that's a Larsen truss, that's a Larsen truss. In between here, we're just putting like a little thin piece that just keeps the membrane from bulging right out, right? Because as it gets filled with dense packed cellulose, it will otherwise bulge right out and actually rest against the sheathing. So it just kind of keeps it all in there.
Did you compartmentalize it vertically? It's pretty tall, huh?
Yeah, no, it runs all 16 feet. So what my insulator does is you can see, I think, you can just see the tape up here from where we cut into the membrane, right? And then they dense pack from the bottom up. And then they go around, they'll end up cutting smaller holes here and there to make sure that they got it all dense packed everywhere.
Wow.
And let me just say one super important thing if you're doing this kind of detail here is to make sure that you come up with a really good detail of keeping critters from getting into this assembly here, right? So either having like insect screen or like core event or something that's meticulously installed, because we did have one little piece missing, and I hear this little mouse run around in there. Luckily, we have that vertical siding, so it's easy to pull a piece off and put a little mouse poison in there. And then I found a hole in the spring after the snow was gone, but watch out for that.